We're gonna create a cabinet family in Revit. I'm using Revit 2024. We just create a new family and we do it in metric. So I'm gonna create a metric casework. We can do it also on a wall-based one. So today we decided to do a metric casework so you can put it anywhere you want. Okay, as you can see, the place to work is completely ready for us. We have some sizes. We can change the sizes over here, the depth, the height, and the width. So for example, we're gonna change the height to 1000 millimeters. Then we hit apply. We see the changes in different views. Okay, so we're going to the front view. We want to create our cabinet. We need to uh, create some similar reference planes. For that, we use the CS on keyboard to create a similar one. We click on the plane that we want to work on. Then we pick up a line and choose our offset. In this case, we want the thickness to be like 15 millimeters, 1.5 centimeters. So we choose 15 millimeters right here. We set up our reference planes and in different directions. And to make it a variable parametric design, uh, in order to be able to change the thickness of the cabinet in future, if we wanted to use different woods, we give it a linear measurement. The first thing, which is really important in Revit, we have to choose a stronger reference line for our size. So if anything wants to change, it changed based on the stronger one. So we do this. And then we create a parameter data for that. So we choose the main frame thickness. And as you can see, we have the frame thickness here. We just choose our dimensions and give it a label that we already created. We can change the size over here. So right now we have everything ready to create our extrusions. So we create an extrusion. I need two different squares in order to create my cabinet. So we can pick up a line, lock it, choose our lines, and as you can see, it's all locked. So if we change the sizes of the cabinet, the height, the depth, and everything, it's gonna change accordingly. Then we create another one right here, and then we lock everything in order to change with the sizes. Now we have our frame of the cabinet right here. We just work on it a little bit. We go to different views, and over here I'm gonna change extrusion start and lock it here for the depth. Now if we go to the 3D view, as you can see, we have the frame of our cabinet ready to go. Then we can go to different elevations, like the back elevation, and create the back of our cabinet with another extrusion. In this case, I want the extrusion to be a little bit inside the cabinet, so I have to change the extrusion end and start in order to have it a little bit inside the cabinet. You also can go to different sites. Like here, you can see what is going on. In this case, I want to change the size of the back of the cabinet to 10. And the thickness of the back, and I'm gonna start it at 5 in order to be a little bit inside the cabinet. As you can see, this is the frame of our cabinet. This is the back part that I created. So we start at 5, we end at 15, so we have a thickness of 10 for the back of our cabinet. If we go to the 3D view, as you can see, we have it a little bit inside our cabinet. And the next step, we want to create a door for our cabinet. The thing that I'm going to do, I'm going to create another extrusion. In this one, I don't want it to go all the way up or all the way down. So I'm going to design this one from this end to this end. And then definitely we're going to lock everything for our parametric design. And I want the extrusion end and the cabinet to be 15 millimeters thick. So now we're ready to go over here. If we go to the 3D view, we can see the door of our cabinet right here. The top and the bottom is not completely up and down based on our design. And then I want to do a countertop for my design. So I'm going to go to the front view right here. I'm going to create some similar reference planes. Again, now I want it to be like 20 millimeters high, 2 centimeters for my countertop stone or whatever material we want to use. If we want to make it parametric as well, so we can use different sizes of stone and countertops, we create another label. The important part again is to choose the stronger reference plane. So it changes based on the stronger reference plane for the thickness. Then we're going to create another label for the countertop thickness. We want it to be a dimension, style, and length, and it should be type for now. And we created our countertop thickness. Then we're going to create another extrusion, and then in a different view we're going to change the extrusion start and end to be as uses us. Okay, so we create the countertop here, we lock everything. And when we go to the right view, for this one I want it to be locked on the dimension of the depth of the cabinet, so I bring it inside over here and lock it based on this reference plane. And I want the end of the extrusion to be a little bit in front of the cabinet door in case water and other materials, other fluids come down the cabinet, don't make any hard thing for us to clean it. So I'm gonna make it 25 over here to see what's going on. Actually, let's make it 30. So this was 15, we'll make it 1.5 centimeters out of the cabinet door to have a clean view countertop. We'll check the 3D as it is completely visible. It's a little bit out of the cabinet door. It seems completely okay. So I want to create a different design for my cabinet door, the different kind of finish. So we can do two things. We can either select the cabinet door, create a void form, void extrusion on the cabinet, or we can change the extrusion and edit the extrusion right here to make it a void part around the center of the cabinet door. So let's change some dimensions here to see everything till now is completely fine. Let's change the countertop thickness to 30. As you can see, goes up. The depth, for example, to like 700. And once as well, the frame thickness can be 25, for example. It's not visible from this side, but you can see the change. The height would go like, for example, to 900. Yep, and this one, for example, to 600. Everything seems to be fine. Everything changes based on the parametric design that we created. So we go back to our normal sizes right here. Example 25. Change everything, we go back. Now that I want to make a void part right here, I want it to be parametric as well. So I'm going to go to the front section right here, the plane that I'm going to work on, and then I'm going to create some new reference planes. In that case, I'm going to select the plane that I want to create similar, type in CS to create a similar one, pick the line, and the offset that I want to be 25 centimeters to 150 millimeters size. Then I'm gonna choose the reference planes that I want to work on, and create two over here, one right here, and based on the top one, which is gonna be this one, another here. So if we want to lock them and make them parametric as well, we create some dimensions. Actually, add some dimensions right there. give it a label as well for our purpose of design. Create a new one and leave it inside the frame. So as always, remember how you name your parameter data to be completely clean, and you can find everything properly. If you want to use it somewhere else, you can easily type in the name, and it is more clean to do so. So we select these other dimensions and label them with the same label. Now if you want to change the inside part, you can always do it the same way. Now I'm going to create a void over here. Remember, we can also change the boundaries, edit the boundaries, and make it void over here. This time we want to do a void extrusion to show you something new. We create a rectangle right here. We lock everything, so if you want to change the size of the inside frame thickness, everything goes with the same sizes. Okay, now that we have our void part right here, if I make this one a little bit realistic, maybe you see there is a void part in our design. Okay. So we want to create a different design in our cabinet, and we want to do a sweep over here. If we want to do a sweep, we select on the sweep, we can pick the path that we want to work with. Keep in mind the path we want to pick or sketch, it has to be in a view that you can actually select the lines for it. So I'm going to do this one right here. We have our four sides. It's a closed space right here. It's a closed path. Then we can create our profile. You can either pick a profile from the previous works that you had, or whatever you have on your computer. You can load a profile, or you can edit a profile and create your own profile. So if I click on the edit profile, it will go on this window, so I can choose which plan I want to work on. So for example, we go to the ref plan over here, we open the view, and we can choose how to create our profile. I'm going to do a different design this time, so I'm going to choose a line. Keep in mind that profile should be always closed as well. So in this case, I'm going to do something like this. We can choose different designs, different kind of lines. For example, something we close our profile and click on finish. And when you click on finish edit mode, you have your profile can show you on the 3D mode. Have your design right here, as you can see. So the reason we did a parametric design is to make some changes in the future. For example, if you want to do a side frame of 15 centimeters, you can change the size right here for a better and more clean design. Now that we created our profile, I want the middle section over here, the void section, to be wood as well. In that case, we're going to go to the front view and we're going to create another extrusion. We want everything to be parametric and change at the same time, so we'll lock everything to the closest line possible. And we want to change the sizes a little bit. The extrusion start, I want it to be a little bit smaller thickness. We can do like maybe 10, and we can go, actually we can go like 5 millimeters of thickness right here. And if we go to our 3D mode, as you can see, it comes out of our profile 5 millimeters right here. If we want to change that, we can do it right here. Let's see how this can look like. Not bad actually, so we leave it at 10, and we have our design right here, as you can see. Now if we go to the realistic again, you can see that we have our profile with our own design, we have our countertop, we have our different sizes right here. So now I'm gonna create different sizes for my cabinet. The first size that I want to use is the same size. So H would be 100 centimeters, and the width would be 90 centimeters, and the depth would be 60 centimeters as well. Now we can create a different one. So in this case, we want the height to be 90 centimeters, the width to be, for example, 60 centimeters, and we want the depth to be a little bit deeper. We will make it 80 centimeters as well. So click on OK. Now we change the depth to 800 millimeters, the height to 900 millimeters, and the width to 600 millimeters. As you can see, everything changes based on Revit, except the profile, which is not a parametric design in this case. And we create another one, for example, with different sizes, like width of height of 100, and the width of, for example, same. Actually, let's do 800 millimeters, 80 centimeters, and the depth of 60, the standard size. And Now we change these ones over here. The depth could be 600. The height would be 1000 millimeters, and the width would be 800 millimeters. You can see we have our design over here, and we click on OK. Now we want to put our and place our door handle on top. In that case, I have a different video for creating the door handle. I have my door handle right here in my computer, so I'm not going to design it again. I'm just going to load it in my video, and I just want to show you a different trick to place the door handles, and it can be a variable size and variable dimensions. I'm going to create a new reference plane. For example, 200 millimeters inside. 100 is too much. Let's do okay. This side. Going to place my door handle 100 millimeters from the top. Now that we have our sizes, I wanna make it fix. Don't want it to change with anything else. It has to be fixed on these planes that is already there, and then we can just open one of the foundries we used in different projects. Yeah, so this one, as you can see, I have different sizes, and for my door handle, if I change the size, it goes smaller or bigger. I just want to use a 10 centimeters or 100 millimeters one in my project. I load it into my project, and I want to do on the front view. These are the planes that I already designed for the purpose of this door handle, and then I'm going to align everything with the door handle and lock it, so if it goes smaller and bigger, the door handle moves with everything else. Now if I go to a 3D view over here, I have the door handle right there. If I change the design, change the sizes, you can see what's gonna happen. You can see the door handle is 200 millimeters. The center of the door handle is 200 millimeters from the side, and 100 millimeters from the top reference plane. If I go with a different one, it's going to be the same as well. Okay. Now you can choose different materials for your countertop, for your wood and everything to be more realistic in your design. So we can go with a kind of maybe marble would be nice. Load it into my project, and as you can see, it's a marble design, and then I'm gonna change the rest to some kind of wood, maybe. Maybe ash wood could be nice for this cabinet. And for the door. We can use same design, same the profile, and the center part can be all hash. Now, as you can see, everything is based on our design. The countertop and the cabinet.